Okay, so in this case, we've got C₂H₆O reacting with O2 and produces CO2 and H₂O, right? And we've been asked, well, what is the volume occupied by the CO2 that's produced, right? And in this particular case, what I'm going to do is, well, I'm going to want to work out what is the amount of substance of CO2 produced, right? Because that's going to enable me to work out the volume. But in order to get to there, I need to work out, well, because I don't actually know what, you know, the mass of CO2 produced or any of those details yet. What I do have is the amount of substance. Well, I have not the amount of substance, but I've got the mass of the C₂H₆O which reacts, right? And based on what I can see in the equation, that I can see that the C₂H₆O is actually the limiting reagent. So it's really going to be the thing that determines the amount of CO2 that's even allowed to be produced in this reaction. And okay, so based on that, I'm going to want to work out the amount of substance of the C₂H₆O first. And I have the mass and I have the formula, right? So what I'll be using is the idea that the number of moles N is equal to the mass divided by the molar mass MR, right? So in this case, we've got the mass. So we know that this from the question is 47.21. But the MR, we're going to need to use the periodic table to work that out. So this is for C₂H₆O, right? So we're looking at MR of C₂H₆O, right? It's going to be equal to what? Well, for C2, if we look at the relative atomic mass of carbon, that's 12, right? So as you can see, we've got a 12. So that's going to be 12 times 2. For hydrogen, you can see the relative atomic mass is 1, right? So it's going to be 1 times, and then H6, right? So times 6. And oxygen, the coefficient is basically 1, right? There's no coefficient written there, so you can infer that the coefficient is 1. So that's just going to be, for oxygen, you can see that the relative atomic mass is 16, right? So it's going to be plus 16. And so if you work that out, that's going to tell you what the MR of the C₂H₆O is going to be, right? And if you do work that out, you should find that you get 46, right? And that's going to be in grams per mole. Okay. And so that's going to be there, 46. Now, if we plug these values in and actually run that calculation, we will be able to work out the number of moles of C₂H₆O. So number of moles of C₂H₆O is 47.21 divided by 46, right? And what's that going to give you? Well, that is going to give you 1.026304. I'm going to just round this down, so put 43, okay? And just leave it at that. That's yeah, okay. So, and that's going to be in moles, right? Okay, so we've worked out the moles of the C₂H₆O, but what we're really trying to get is what's the amount of substance of the CO2, right? Because that will then enable us to work out the volume. If we look at the balanced equation and we set up a bit of a molar ratio comparison, so this is in the sense of the number of moles of C₂H₆O compared to the number of moles of CO2, what you find is that you're going to have effectively for every 1 mole of C₂H₆O, you're going to have as 2 moles of CO2, okay, right? And on that basis, we can say that, well, the number of moles of CO2 is equal to 2 multiplied by the number of moles of C₂H₆O, right? and we have this value, we've worked this out, so effectively that would be equal to 2 multiplied by this value up here effectively, right? So 1.026303, okay? And this is going to give us a number of moles of CO2. So if you do have a go at working that out, you should find that you get 2.0526087, right? That's going to be in moles, right? Okay, so at this stage, we have the number of moles of CO2 now, right? And remember, what we're trying to actually work out is the volume occupied by the CO2, specifically at room temperature and pressure, okay? Now we know that for a given 1 mole of a gas is going to occupy 24 decimeters cubed. So if we have got the number of moles of this gas, if we multiply it by 24, we're going to be able to work out the volume that this particular amount of substance is going to occupy under those specific room temperature and pressure conditions. Okay, so in effect, what we need to do is therefore, okay, the volume, right, of the CO2 is going to be equal to 24 multiplied by effectively this value up here. So multiplied by 2.0526087, right? And that's going to be 49.262 6088, and that's going to be in decimeters cubed. Okay, now the question does specify that our answer should really be to a maximum of 2 decimal places, right? So we do need to make some adjustments here. If we do round this now, we get 49.2, and then we just round that down because there's a 2 there, right? So it's going to be 26, and that's going to be in decimeters cubed, and that's 2 decimal places, right? So this would be, in this case, this would be our answer to 2 decimal places.